power. A block of mass 10 kg, 10 kg, rough plane, so we have friction, angle 30 degrees, force 120 applied at this angle, and we have the angle 20 degrees. There is a force resisting the motion of the block. 200 joules is the work done against this force. Moved 5 meters up the plane. Find the speed when it has moved. Okay, so this is the concept. So first of all, we need to use this component of the pulling force 120 newtons. Okay, so here we need to find this component using cos, because this is the right angle triangle. We know the hypotenuse is 120. We are looking for the adjacent, so we have 120 cos 20 degrees for this component. And we know that we have this component actually, and we also have the weight forces in this direction, but we don't care about them because we are using energy method, so this is much faster. And we know that initially at rest, in the end we need to find the velocity. We know the distance is 5 meters up the slope, diagonal distance. So the vertical distance is, if we look at this triangle, we know the hypotenuse is 5. We are looking for the opposite. We use sine, 5 sine. So sine 30 is 1/2. This is the vertical height. So because of the resistance basically means we have friction. Okay, so at first there is the friction is when it's moving here. So at first it is colder, in the end it is hotter. So just think of friction as something rubbing, so it's gonna be warmer. Okay, so now we use energy lost equals energy gained. We are losing the work done by the engine, and do we have work done by the engine? Oh yeah, so actually we don't have work done by the engine. We have work done by this rat force here. Okay, so there is no engine. We have pulling force from the rope, so this is the work done by the pulling force of the rope, but we only use the component which is parallel to the slope. So this is the work done by the pulling rope, and the energy gained, we have potential energy because it's going somewhere higher. We have kinetic energy because from 0 we have some velocity, it's going faster, and we have thermal energy because of the friction or resistance. So for the work done by the rope, we use this component of the rope pulling force here times the diagonal distance. Delta PE we use mgh. Delta KE we use 1/2 m delta V squared, and for the thermal energy it's given 200 joules. So from here just use a calculator, simplify things, and solve for V, and we get this number. Okay, so in conclusion, in 3SF with the unit, this is the final answer. Alright, I'll see you again next time.